Welcome to class today, geometry students, on this Monday. Hope you guys are doing well on the 14th. There'll be a little bit of noise in the background. I'm making a video today, Sunday afternoon, and my kids are playing video games. My wife's doing some cooking and stuff like that, so there will be some noises in the background, so do understand that. I try to keep it as quiet as possible, but occasionally that will happen. Now, let's see here. Welcome to class Monday, and oh my goodness. Jace, I wanted to apologize to you. I had to leave that volleyball game early on Friday. Hated that for you. I've coached for years. I had forgotten that when the score is like 25-23 and 25-20 and 25-23, it can go up to 2.5 hours. So we were there for the whole thing from 5 until 6:30. Well, I was there to see you and your family at the recognition time, and then the game until 6:30. But we had to leave at 6:30 due to other obligations. But I did enjoy the game, and I have yet to go online and see if you guys even won. So I hope that you did win that game. Here are some announcements coming up, guys. There will be a test on Friday. Notice the smiley face. I'm sure you're excited about that. You'll have a review sheet on Thursday. This is your first grade of the 9 weeks, so it's important. Please work hard. Work hard in the review sheet and make sure you're ready for this test. Please, it's very important that you do that. You owe me homework from Thursday. Now, I did not go to Berean and look. Sometimes you guys listen to the lesson and do the homework and get it all done in one class period. That's fine. So if you turned this in Thursday before you left, that's fine. Don't think that I did not get it. I just have yet to check my box. But if you did not turn it in, you owe me homework now, so please turn that in. It's page 188, 7 through 25. Oh, that's from Thursday. Okay? All right, moving on. Students, in the past, let me grab a quick drink of water here. In the past, we have studied the Pythagorean Theorem. We studied that 2 years ago when you guys were sophomores. I had 3 of you in class, and we studied that then, plus I know you also had it in middle school. And so you've studied the Pythagorean Theorem before. We have also studied what writing the converse means. For example, remember I said, let's see, if a triangle has a right angle, then it's a right triangle. Well, you could turn that around and say, if a triangle is a right triangle, then it has one right angle. That's called writing the converse. It's when you switch the if and the if and the then around, okay? If you have a quadrilateral with 4 right angles, then you have a rectangle. Well, you could say, and by the way, every converse is not necessarily true. I'm just explaining how to write the converse. The converse of that would be if you have a rectangle, then you have 4 right angles. And so the converse is when you switch the if and the then parts or the hypothesis and the conclusion around. We've done that before. So we've studied the Pythagorean Theorem before. We've studied writing the converse before. Let's put the two together. And let's take a look at the converse of the Pythagorean Theorem, okay? So let's put the two together, and let's take a look at the converse today of the Pythagorean Theorem. So we're going to take the Pythagorean Theorem that you've learned, and we're going to write the converse of that and kind of study that today. All right, so here we go. Write this in your notes, please, if you would. Your heading today is the converse of the Pythagorean Theorem. The lesson number is 4.5, and the date today is the 14th. 10:14, okay? The converse of the Pythagorean Theorem, lesson 4.5. The date's the 14th. You know by now I go pretty fast, and I just trust you to pause the video and get caught up as you need to. I know it's a big theorem, but you need to write this down. This is the converse right here of the Pythagorean Theorem, okay? Remember this. The Pythagorean Theorem is if you have a right triangle, then the sum of the squares of the legs equals the square of the hypotenuse. In other words, L squared plus L squared equals 8 squared. Well, we're going to go backwards today, and we're going to say, write this down, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other 2 sides, then the triangle is a right triangle. Now that might or might not make a lot of sense to you, I don't know, but I'm going to explain it better in just a second. But go ahead and copy this down. If the square of the length of the longest side of a triangle is equal to the sum, that means you add the squares of the lengths of the other 2 sides, then the triangle is a right triangle. Okay? Now again, if you need to pause the video, go ahead and do that. I'm going to move on. I want you to write this triangle in your notes. Would you do that, please? Copy this triangle in your notes. Now here's what this theorem is saying. I'm going to explain it very well so you'll understand it. It's saying if you take the longest side, let's go ahead and put L squared plus L squared equals h squared. Okay, students? Now, here's what this theorem is saying. We don't know if we have a right triangle because we don't have a right angle symbol anywhere. But here's what this theorem is saying. It's saying if you take the longest side, which is this side here, and you put it in place of the hypotenuse like this, okay? And then you take the other two sides, not the longest, but the other two sides, and you put them in places of the legs like this, and you go ahead and simplify this. If you get out a true statement, then you know for sure this is a right angle. So let's see what happens. We know for sure that 12 times 12 is 144. We know that 16 times 16, I think, is 196. No, 256, not even close. So 256. And we know that 20 times 20 is 400. Okay? Now, add these two sides together, or these two numbers together, and look what you get. You get 400. So 400 equals 400. So we got a true statement. If this number here is the exact, and I do mean exact, number is this over here, then you know that you have a right triangle. So if this number right here would have been 399.9, then no, you don't have a right triangle. These numbers have to be identical. So we ended up with 400 equals 400. That checks. That's a true statement. Both numbers are the same. So you say, yes, I have a right triangle. Isn't that easy? That's all you have to do. And we're going to learn some more stuff today, but that's really simple. That's all this theorem is saying. So in the past you learned if you have a right triangle and you're missing one of the sides, you could use the Pythagorean theorem to find that one side. However, now we're learning something else. Now we're learning if I give you a triangle with all three sides, you can run a little test to see if you have a right triangle. Now, we saw that we do have a right triangle, which means we have a right angle somewhere. Do you know where the right angle is? It's always across from the biggest side. So here's the biggest side. Go straight across to that angle right over here, and you know that's where your right angle is, right there. There's your right angle. So that's really cool, and that's called the converse of the Pythagorean theorem. So let's practice a couple of these now, okay? We're going to try one. Just one, it looks like, right? So here we go. Take some notes on this. I'm not going to give you a bonus point for this, but you can write this down or work ahead or watch me do it, whatever. I want you to answer the question, is this triangle a right triangle? All right. Well, here's what we're going to do. We're going to go ahead and set up our Pythagorean's theorem. L squared plus L squared equals h squared. We look for our longest side, which is this side here, and we always put the longest side in for place of the hypotenuse, because the longest side, if there's going to be a hypotenuse, if you have a right triangle, the longest side is always going to be your hypotenuse. And then for one of your legs you put a 9, it doesn't matter which one, and the other leg you put a 40. Well, let's see what happens. 9 times 9 is 81. 40 times 40 should be 1600, I believe. I'll check that and make sure. And then 41 times 41 would be 1,681. So we're looking pretty good. Add these two numbers together over here, and you do get 1,681. So the answer is yes. Yes, we have a right triangle. Now, that won't always happen. Sometimes the answer will be no. But if these two numbers are exact, they equal each other, then yes, you have a right triangle. Okay? Now, let's continue on. All right? I think that's pretty easy, isn't it? That's not too bad. That's called the converse of the Pythagorean theorem. Now, guess what? You can also decide whether a triangle is acute or obtuse or right without knowing any of the angles. Is that cool or what? I mean, that is really, really cool. Okay, so here's how you do this. Okay, I want you to take some really good notes. There's 3 scenarios I would like you to write down. You can decide whether a triangle is acute, obtuse, or right. Of course, we already know how to do this when we just learned how to do the right triangle, but without knowing any of the angles. So please write this down. Let me show you how to do this, okay? Number 1, write this down. You know what? I don't like this a squared plus b squared thing. I really don't. I'm not sure why I did that. We use L. You know what I mean? So go ahead and change that. Let's put L squared plus L squared equals the hypotenuse squared. Make that L, L, and H, okay? So if you substitute your numbers in for your L, and your H, and see this inequality, and you get out the left side's bigger than the right side, then you know you have an acute triangle. There it is. That's a formula you got to memorize. You got to know that, okay? No longer is it an equal sign. We're saying if you square the leg, add them together, square the hypotenuse, if these two legs are bigger when you add them together than the hypotenuse squared, then it's an acute triangle, okay? Now here it's kind of the opposite. And again, I'm sorry I did not use the L's. I really should have. I don't like that at all. So go ahead and put L squared plus L squared equals H squared, if you would, please. So here's L squared plus L squared equals H squared. Okay, now look what happens here. If you square the leg, and add it together, and square the hypotenuse, and this side over here with the legs is less than the hypotenuse, then you know that you have an obtuse triangle. Pretty cool. I would love to get into the proof of this and spend a lot of time doing that, and we would do that in a regular Track 1 geometry class. We just don't have the time in here to do that. And also I try to make the homework a little shorter for you guys. If it was a different class, I would actually make it a little longer, a little more difficult, but I try to give you guys a little more time in class. I try to keep it basic, just for a regular average geometry class, which you guys are not just average students, you're great students, but in math, we try to keep this just a little more general. So you would get out an obtuse triangle if you square the two legs and add them, and it's smaller than the square of the hypotenuse. And then you know the third scenario. Go ahead and write it down. We just learned this, right? Did we not just learn this? If you square the leg, and add them together, and they equal the hypotenuse, then you have a right triangle. We just learned that. Remember? Right back here. We squared the leg, squared the hypotenuse, and the two numbers equal each other. So we knew we had a right triangle. So we've already learned that. So go ahead and copy that down. Make sure you have all three scenarios in your notes. If you need to pause the video, feel free to. I'm going to go ahead and move on. So here we go. Is this triangle acute, obtuse, or right? Well, let's find out. Here we go. Let's use our formula. Let's put L squared plus L squared. Now look what I'm going to put. I'm going to put, is it less than, is it greater than, or is it equal? We're going to find out. I put all three of them. All right, let's find out. Now, we know for the H, we put our largest side. Now be careful here. I do not, listen to me students, I do not want you to use a decimal, okay? However, you might not know if this side here is bigger than these sides unless you type it into your calculator and get an idea of what the decimal would be. Now I'm going to tell you right now, it is bigger than 5 and 4. The square root of 35 is going to be 5.9 or something to that effect. I'm checking it out right now. If I can actually hit the right buttons, 5.91. So the square root of 35 is 5.91. Now do not use that decimal. I just wanted you to see it was this side here was bigger than this side and bigger than this side. So this is the biggest side, so it goes into your hypotenuse. So I'm going to put square root 35, and then of course we square it because of that 2 right there. Now for the other leg I put a 5 or a 4, it doesn't matter. And for the other leg I put a 5 or a 4, it doesn't matter. All right, now let's see what happens. So of course it's going to be less than, or it's going to be greater than, or it's going to be equal. Let's see what happens. I'm going to save a step and do all this in my head. 5 times 5 is 25. 4 times 4 is 16. So 25 plus 16 would be 41. So I get out 41 over here. Now you should remember from the past, whenever you square a square root, you get what's on the inside. And that's why I didn't want you to use the decimal. Don't use the decimal, use the square roots, okay? So when you square a square root, it basically cancels out the square root and you're left with 35. Now, let's see. 41 is what? Is 41 less than 35? No. Is 41 equal to 35? No. 41 is greater than 35. Let's go back a page and see what that means. Whenever your two legs that you add together here are greater than the hypotenuse squared, you have an acute triangle. There it is right in front of you. So is this triangle acute, obtuse, or right? It's acute. That means all the angles are smaller than 90. All of the angles are smaller than 90. So there we go. Let's try another one. You can work ahead or watch me. Is this triangle acute, obtuse, or right? And here's my three sides. Well, let's go ahead and use our formula. L squared plus L squared. And then is it less than, or is it greater than, or is it equal then your h squared. Now, for h, you put your biggest side, which is 15, so I'm going to go ahead and put 15 squared. And then for your legs, it doesn't matter which order. I'm going to put my 12 first. It doesn't matter. 12 squared plus 8 squared. And then it's either going to be less than, larger than, or equal to. Well, 12 times 12 is 144. 8 times 8 is 64. And 15 times 15, I believe, is 225. Let's see if it is. And let's see, yep, 15 squared is 225. Of course, we're not sure. We're either going to have less than, greater than, or equal. If you add these two together, you should get 208, I believe. I did it in my head, but I hope that's right. 208 is less than 225. Let's go back 2 pages real quick. There it is, right here. Whenever your leg squared plus your leg squared is less than your hypotenuse squared, it's an obtuse triangle. So this triangle here would be obtuse. The one before was acute. 41 was greater than 35. All right? Not too bad, I really don't think. All right? We got 2 more and we're finally going to be done. Why don't you, well, you know, I could give you a bonus point. You have so many bonus points in your account right now. I just don't think that's necessary. And we don't even have a quiz this week for you to get rid of some of them. So you can work ahead or watch me. I'm going to go really fast on this one. We have L squared plus L squared. I'm not going to put anything here. I'm not going to put less than or greater than. I'm just going to leave it blank and put an 8 squared. Okay, biggest side is an 8, so I've got 8 squared. Then over here I've got 6 squared plus 5 squared. Let's see, that would be 36 plus 25, and then a 64 over here. And then you would get a 61 and a 64. So 61 is less than 64. All right, let's go back and look at our formulas again, make sure we see this. That's obtuse. Whenever you add your 2 legs together and it's less than the hypotenuse, that means you have an obtuse triangle. So this triangle here would be an obtuse triangle. That means one angle in the triangle is bigger than 90. And now the last one, we're finally done. I wanted you to try one without seeing the actual triangle. It's not any different. I just want you to get used to understanding you can actually figure out what kind of triangle you have without even seeing it. You just take your biggest number, which is 37. That would go in for your hypotenuse. And then your other 2 numbers would be your legs. So your 12 squared and your 35 squared. And then, of course, 12 squared is 144. And then 35 squared would be 1,225. And then 37 squared would be 1,369. And if you add these 2 numbers together right here, you will get 1,369. 1,369. Those 2 numbers are equal, so we have a right triangle. Pretty simple, students. It really, really is, okay? I want you to go ahead and get started on your homework today. We are right on schedule to have our test this Friday, a lesson today, a lesson on Tuesday, a lesson on Wednesday, a big lesson on Wednesday, so you have to really, really be ready to work hard. A big lesson on Wednesday, and then on Thursday you'll have a review sheet and a test on Friday. Please don't hesitate to call or email if you have any questions.